Hey, welcome back. This is 11.4 now. We're going to do equations that have the quadratic form. And so basically you put anything in for x, and so long as it has this overall ax squared plus bx plus c form, you can use the methods that we use for factorization and even the quadratic formula in order to solve these things. Okay, so quadratic in form. And literally put anything there. So you could have a happy face, or just mildly happy face squared, plus b face plus c equals 0. And we could use all of our methods to solve for the face. Okay, so let's look at one. Here's number 2. I have x to the 4th minus 13x squared plus 36 equals 0. Okay, so compare this to this. X squared minus 13x plus 36 is 0. So I could factor this, and I have x minus 6. Well, that won't work, right? I need a 13 resulting. It's minus minus. So probably I would say 12 and 3, but 4 and 6, or 4 and 9, I mean 4 and 9. And then we could solve that. X is 4, x minus 9 is 0, so x is 9. Okay, so you remember how to do that. This has the same form, doesn't it? Okay. The only difference is that I have an x to the 4th and then an x squared. So I mean, even before we get to factoring it, you can kind of think of it, the face, that the thing that's being squared here is x squared, because x squared, the something squared, the something is the x squared, and then minus 13 times something, in this case it's the x squared, plus the 36. Okay, so when I go to factor it, it's going to be the same as what we did over here. Be minus 4, minus 9. It's just instead of putting x and x, I'm putting in now whatever's in the parentheses I have. It's the x squared, right? That's the new kind of thing. Squared and x squared. And then the rest is the same. You just set them equal to 0. So this will be, you could use the square root property. You could factor it again if you want, which is x minus 2, x plus 2. So here is x equals plus or minus 2. And then over here, let's just use the square root property. It's quicker. X equals plus or minus 3. So I got 4 answers now. Okay, but it's not anything real new. It's just being able to kind of establish this resemblance, resemblance to a quadratic formula that we already know how to factor from our previous work. Okay, so just being able to identify that correlation. Okay, let's look at another. X to the 4th plus 4x squared equals 5. So quadratic forms, you always want to get them on set equal to 0. Then the thing that's being, the face, so to speak, the quote-unquote face, is x squared again. Okay. So we'll have, instead of x and x, we have x squared and x squared. And then we need plus minus, and the 5 to be plus, the 1 to be minus. Then we could set each of these equal to 0 and solve both of them. Whoops, I'm trying to get too far ahead of myself. So here, x squared is negative 5, and we're going to use imaginary numbers here, so those are just fine. Plus or minus square root 5i. Then the other ones, okay, so again we have 4 answers. Okay, let's look at number 8. This one's a little tricky. Okay. So what is the thing that's being, the ax squared? What is the x squared? How is this related to? I mean, there's three terms there. You could see that clearly. So we're maybe not convinced it's quadratic. But if you were to rewrite it as a square root of x squared plus, just a square root of x minus 6, then it's just like the x squared plus x minus 6 is 0. So you could factor that, except now with a square root x instead of x. Right? Okay, so we're going to go square root x and square root x. Then we need a plus minus, and we need the bigger one to be plus. Okay. Then we're going to set each equal to 0. And solve. Okay, so I have a square root of x equals -3. Square both sides. I get x is 9. Now you have to check your solution here because we've squared both sides. There's an issue, right? So we have to go back to the equation here, the original equation, and check it. So I'm going to go back to right here. Square root of 9 plus 3 is 0. And you have to show me the check. 3 plus 3 is 0. No. 6 is no. So we throw that solution out. Then the other one, square root x is 2. Square both sides, x is 4. Check it. And that one works. So that will be our only solution. X is 4. Okay. Okay, next one is a video quiz. Video quiz, 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 video quiz. This should be the fourth problem in homework 7. Okay. So this time the thing is the x plus 3, right? Because it's kind of like originally x squared plus 7x minus 18 is 0. Okay. Okay, so here we go. I'm going to put x plus 3 here and x plus 3 here. And then I need plus minus, and then two numbers that subtract to give me 7, but multiply to give me -18. So it'd be 9 and 2. The bigger one has to be positive. And then you just take them, set them equal to 0. You don't need the parentheses at this point. So one solution, -12. The other solution, -1. Okay. Let's get another. It's number 18. So we have an even wilder expression. X squared minus 2x squared minus 11 times x squared minus 2x plus 24 is 0. Okay, so our thingamajig is the x squared minus 2x. You don't really need the parentheses here, but I don't know. I'll put them in anyways. Then it has to be minus minus, and two numbers that multiply the 24 but add the 11. So 8 and 3. And then set each part equal to 0. And you have two more quadratics. Okay, hope we can factor those. So it looks like x minus 4, x plus 2. So x is 4 and -2. And the other guy, so x is 3 and -1. So 4 solutions. Okay, pretty neat. Let's try 22. So I have 20x to the -2 plus 9x to the -1 plus 1 is 0. So this time it's the x to the negative 1. So you could rewrite it as 20 x to the negative 1 squared plus 9 times x to the negative 1 plus 1 equals 0. Okay. So I'd have, it has to be plus plus, it has to be 1 and 1, and then it looks like 5x to the negative 1, 4x to the negative 1. Okay, then set these two formulas equal to 0. Five x to the negative 1 is the same as 5 over x. I have a restricted value of 0. Okay, x cannot be 0. That doesn't mean it has no solutions. This is just if you get x as a solution, then you have no solutions. Okay, you need to multiply to get rid of that denominator, so I multiply both sides by x. I'll get 5 plus x equals 0. Subtract 5 on both sides. Negative 5, that's not 0, so that's one solution. For the other guy, again, we can't have 0 as a solution. I'm going to multiply both sides by x to get rid of the denominators. So we get 4 plus x is 0. In other words, x is negative 4. And again, that is a solution because it's not 0. Okay. Okay. Next one's a little more complicated. It's the same idea though with the negative exponents. So we have x to the negative 2 minus 6x to the negative 1 equals negative 4. I'm going to add the 4 to the other side. And its quadratic form is like this. So sort of the face part of it is the x to the negative 1. Then we're going to factor. Has to be minus minus. And this is where you get in the trouble, right? The only possibilities are 2 and 2 or 4 and 1. And neither of those will add to give you 6. So sadly enough, you got to go to your quadratic. Okay. Instead of putting x equals, you have to put the x to the negative 1 equals whatever this thing is that's being squared. Okay, so I got x to the negative 1 equals, and then you could identify your a is 1, your b is negative 6, and your c is 4. Okay, so you have negative b, negative 6 is 6, plus or minus the square root of b squared is 36 minus 4 times a times c, all over 2 times a. So I get 6 plus or minus the square root of 36, that'll be minus 16, which will just be square root of 20 over 2. So I get 6 plus or minus 2 root 5 all over 2, and you could simplify that into 3 plus or minus root 5. Okay, and we're not done. So one answer is from the equation x to the negative 1 equals 3 plus root 5, and then the other one is from the equation x to the negative 1 equals 3 minus root 5. Okay. Okay. So I have to solve for x. And right now I have 1 over x. X to the negative 1 is 1 over x. Okay. I could cross multiply if you wish, but it's a bit easier rather than to do that to just flip both sides. So you could rewrite it as x equals 1 all over 3 plus root 5. Okay, long story short. I mean, technically what you do is multiply both sides by x, and at the same time you're dividing both sides by 1 over 3 plus root 5. Okay, and you end up with the same thing. Right, because over here the x's will cancel, and that'll give you the 1 all over 3 plus root 5. Over here the 3 plus root 5's cancel, and you're just left with the x. Okay. Okay, the problem with this answer is not rationalized, so I need to rationalize it. So I get 3 minus root 5 in the numerator. Downstairs I'll have 9 out outer minus 3 root 5, inner plus 3 root 5, and then last minus root 25. So it'll be 3 minus root 5 all over 9. These cancel, minus 5. So x will equal 3 minus root 5 all over 4. That's one answer. The other answer over here, again, you could just flip it, both sides. Whoops. So originally, if you rewrite x to the negative 1, that's 1 over x. The other side stays the same. Then you could flip both sides. So instead of 1 over x, x over 1. Instead of 3 minus root 5, 1 over 3 minus root 5. And again, you have the same problem where you need to rationalize denominators. So we'd have 9 minus 5 again, and that would be 4. Okay, a lot of work. Let's look at one more, and then I'll go peek at my math lab, see if there's anything crazy on there. Okay, so another quadratic form. This time the sort of face is x to the 1/5. Okay, so hopefully you can factor this. We'll have x to the 1/5 times x to the 1/5, and then it looks like plus 2 minus 1. Okay, set each part equal to 0. Move the 2 to the other side, and then raise both sides to the 5th power. Negative 2 times 4, 8, 16, negative 32. Raise both sides to the 5th power. X is 1. Okay. Odd root, you don't have to check the answers. So those are our 2 answers. Okay. Okay, so hopefully that kind of explains it. It's not hard, so if you didn't see it, it'll just click. You know, it's one of those things you kind of either get it or you kind of don't. But you might be overthinking it if you don't get it. But kind of just keep this in mind. You're trying to put it into kind of or make a relation to one of your quadratic forms. But you just have to kind of figure out what the face is, what the thing is that they're squaring instead of just x. Okay, anyways, let's look at my math lab, see if there's anything. Only 2 more sections after this, which is kind of crazy. Okay. Okay, so let f of x equal all this stuff. Find all x such that f of x equals negative 11. So basically you're going to plug negative 11 in for f of x. And we have x squared plus 5x minus 13 squared minus 12 times x squared plus 5x minus 13. Okay. And then notice it's a quadratic form and solve it. So set it equal to 0. Factor it. So we need probably minus has to be probably 11 and 1. Okay. So we'll have x squared plus 5x minus 13 minus 11 is minus 24 equals 0. And then x squared plus 5x minus 14 is 0. Just combining minus 13 minus 1. Then hopefully we can factor these characters. And it doesn't look like we can. No. I think x plus 8, x minus 3 over here, 7 and 2. x plus 7, x minus 2, so negative 8, 3, negative 7, 2. 3, 7, 2. Okay. Look at this guy. Find all such a, okay, so again, you're going to place 4 in for f of x and then solve that thing. Okay, so as usual, set it equal to 0. And factor it. Set each part equal to 0. I'll go ahead and distribute this thing. So I have 8 over x plus 6 minus 1 is plus 5. Then the other guy, 4 over x plus 7. Okay, x can't be 0 for these. Multiply both sides by x. So that one works, negative 8/5. Over here, same deal. You can't have 0 for an answer. Okay. Find all x such that f of x is equal to g of x. Okay. So f of x is x over x minus 2. And then g of x, where'd it go? Okay, so g of x is 9 times the square root of x over x minus 2 minus 18. Okay. So x over x minus 2 as it sits is really the square root of x over x minus 2 squared. Okay, so that'll give you the quadratic form when you move the 9 square root x over x minus 2 and the negative 18 to the left. Okay, so you have the square root x minus 2 squared minus 9 square root x over x minus 2 plus 18 is 0. Right, so we have 6 and 3, and then this thing is the x over x minus 2. Okay, and then we set each of these equal to 0. And we have a lot to worry about with regards to our solutions. Okay, so we need, in particular, x minus 2 to be not equal to 0, but greater than 0, okay, for the radical. And so we don't have division by 0. So we'll just say x minus 2 has to be greater than 0. So x has to be greater than 2 in our solution for either equation. Okay, so I'm going to isolate the radical part. Get square root of x over x minus 2 equals 6. I'm going to have to square both sides. Because I'm squaring both sides, I'm going to have to check my solution. Anyways, 2 equals 6. Now I'll multiply both sides by x minus 2. move the 6 over, and x is 12/5. It's bigger than 2, so it should work. Let me check it in my original equation. 12/5 all over 12/5 minus 10/5 equals minus 6 is 0. Okay. So this will be the square root of 12/5 divided by, in other words, multiplied by 5/2. Minus 6 is 0. The 5's cancel, and you end up with square root of 6, which is not going to work as a solution. Let me make sure I didn't make any mistakes. Oh, back here, this should be 36. Sorry. Let me go back through here and do all this jazz. Okay, so 72 over 35 all over 72 over 35 minus 2, which is the same as 70 over 35. So you get 72 over 35 times 35 all over 2, and then that'll work. So you get the square root of 36 minus 6. 2 goes in the 72 36 times. Those will cancel. And you get 6 minus 6, which is 0. It works. Okay, let's try the other one. I'll isolate the radical. Square both sides. Multiply both sides by x minus 2. I'll go ahead and distribute. So you get negative 8x equals negative 18. Divide by 8, negative 8 that is. You get 18 over 8, which is 9 over 4. Then I got to put it and check it. Square root of 9 over 4 all over 9 over 4 minus 8 over 4 minus 3 should equal 0. So I have the square root of 9 over 4 times 4 over 1 minus 3 is 0, and that works. Okay, so square root, that'll be 9 in here, and then 3 minus 3 is 0. Gee willikers. I won't put one like that on a test, but 72 all over 35, comma 9 over 4. Okay. Find all x such that f of x exceeds g of x by 8. Okay, so f of x should be bigger than g of x by 8. So f of x will equal g of x plus 8. Okay. So I'm going to push everything on one side to get the quadratic form. Okay. So I'm going to have to go 3x minus 3 to the negative 1. X minus 3 to the negative 1. And then what do we need? Probably 4 and 2. Yeah, so 4 would give you 12, and then subtract away a 2. Need the bigger one to be negative. This will be positive. Okay, so this will be 3. X minus 3 to the negative 1 is just 1 over x minus 3. So 3 over x minus 3 plus 2 is 0, or 1 over x minus 3 minus 4 is 0. These are rational equations, so state the restriction. X minus 3 cannot equal 0. In other words, x cannot be 3 for our answers. Then we multiply everything by x minus 3. That's the LCD. So I'll get 3 plus 2 times x minus 3 equals 0. So 3 plus 2x minus 6 is 0. 2x minus 3 is 0. And then 2x would be 3, and x would be 3 halves, which is not equal to 3, so that one's good. Same game for this guy. X minus 3, x minus 3, distribute. So get 1 minus 4 times x minus 3 equals 0. 1 minus 4x plus 12 equals 0. Minus 4x plus 13 equals 0. Minus 4x equals negative 13, so x is 13 fourths. Okay, again, that's not equal to 3, so that will also work. We have comma 13 fourths. And then I got rid of that one. Okay, so that should get you through it. Those are some crazy ones. Okay, so we'll leave it at that, and as usual, thank you for watching, and we shall see you next time.